Hello, everyone. Thank you for joining us today for EA's Education Series webinar. Today, we will discuss a manual for Ethereum network operations for public-private networks. Today's call is being recorded and will be available to all attendees and the public on the EA YouTube channel soon after today's presentation. The EA enables organizations to adopt and use Ethereum technology in their daily business operations. The EA empowers the Ethereum ecosystem to develop new business opportunities, drive industry adoption, and learn and collaborate with one another. We welcome any and everyone to join and become a part of our global community. At this time, we are pleased to introduce our presenter, Antoine Toulme.
Thanks, Brittany. Hi, everyone, and welcome to this webinar. This webinar is yours, and we're going to talk a lot about how you can help and how you can participate. Just as we fill this room right now, we have a few folks joining. That's great. So the topic of this webinar, as Brittany said, is going to be all about how you can run nodes, how you can do the best job at running those nodes, and we'll go into detail on that. First, a little bit of a preamble. So we're going to talk about some subjects that may be very technical and go deep, and I hope to capture your attention on that and provoke questions from you, but also maybe things that may seem mundane or that you've seen before. So I'd love to get your feedback on all those things, like whether it's too deep, whether it's too basic. I want to understand where your interests lie, and I want to make sure that I'm able to answer any questions. So at the end of this session, we'll make sure to have plenty of time for any questions that may arise, and to even have some sort of a discussion about what's the best way going forward. I should say this webinar comes with opinions, mostly mine. They also come from my current work on all those clients. So hopefully you enjoy this. Now let's go. First off, who am I, right? I'm been doing open source software for over 10 years. I'm a member of the Apache Software Foundation. My day job is to be the manager of the Splunk blockchain and DLT team. And I currently am the chair of the testing and certification working group at the EA. You can find me at antoine@themachine.io. You can also visit my website, themachine.io. So feel free to take a look, let me know if you have any questions about blockchain, anything like that. I'd be so happy to have a discussion with you. So as I mentioned earlier in the preamble, we're going to talk about operating a node, and we're going to talk about operating a node from different points of view, from the management of secrets and security. We're going to talk about how you make sure to not have data loss with redundancy. We're going to talk about account management, and we'll talk about Ethereum account management as part of this. We'll discuss network security, a little bit of some of the well-known attacks, things like that can happen. We'll discuss upgrade policies. It's kind of fresh right now. It's fun to go into that a little bit. And we'll discuss about a subject that is really dear to me, telemetry. So first, a few horror stories. So to make this talk a little less about slides, I wanted to show you a few horror stories that I experienced myself, doing work with Besu, with Quorum. I wanted to talk to you about my personal experience, and I wanted to show you just a little bit about development and testing, how that feels like when you're actually in the trenches and trying to make sense of stuff. So there's going to be some tropes here and some very basic and well-known things that you probably have had experience. And if you haven't yet, well, you're due for some. The first one that happens all the time is this one, right? This is an issue that is currently logged against Besu. You have a very miscontent and happy user who's saying, hey, I built a cluster using the IBFT consensus algorithm of 4 different nodes. When I put this together, I'm following best practices. I'm making this happen together. I'm getting those different nodes on different IPs, different machines, and I try to connect them. Nothing happens. What are my issues here? Is that we're losing each other? Is that the network doesn't work? How do we debug this? How do we make sense of it? Is it because we have a firewall, or maybe just a rule around a type of connection, or is the software itself faulty? right? So to give you an example of the complexity of it, if you look at the actual issue here, this poor man is trying to understand that, he's got those boot nodes, they actually, in this particular case, run on one server. And he says, I may come back tomorrow morning and find the nodes are synced after a restart last night, but it seems no certain way to guarantee sync up. So in a way, this is a welcome to blockchain, reminder, where pretty much every node you run can be broken by a remote node if there's any issues with it, right? This is still at this point a crucial problem in adoption, where you're not able to get as much data or understand what is broken and what doesn't work. So right now, to be fair, this bug is still open. We're still thinking through it. And what's really interesting is that is only giving us what is not private and what is not confidential. So an added problem to this is that when you run your own ops, there's a lot of stuff you just don't want to show to the rest of the world. And it becomes a bigger issue when you're trying to debug things with an open source software. So you can only open so much in that particular problem. The same user also logged another bug where he was having issues with connecting to the JSON RPC port, and could see it working locally using the IP, but then trying to use the host name from remote would not work. So what we're seeing is that all the issues you may have had with Web 2 software around DNS, firewall, network security is being compounded by all the things you can have as part of a blockchain operation. Another one that I really love, and I hit this myself, is the Go Ethereum importing state entries, endless logs. So this one is really interesting because it shows that it doesn't matter how good your network is, your bigger problem is your hard drive, right? So if we go into this issue a little bit, this is a user who's been trying to sync for about 40 hours, which is not that long. I tried for way longer than that, and still is unable to catch up to the head. And this is a response from the developer on the Geth side saying, hey, it's not because you think you've got all the blocks that you're actually syncing to the head of the chain. So in Ethereum, we have headers, which come first, which allow you to have some sort of guarantee that you're progressing to the head of the chain. Those block headers then are accompanied by block bodies, which are downloaded separately. Those block bodies are not enough. You also would want to have access to all the state data. And this is what he goes into here. He says, well, it's not enough for you to get all the blocks, but you're going to want to be able to get also all the state data, which is downloaded separately and is downloaded after all the blocks are here, so you can actually check that the state makes sense. And since the network is moving forward, your state will eventually deprecate and decay, so you have to be fast enough when you sync, right? And one of the big things that he mentions is that you will have a need for an NVMe drive, SSD. You cannot use a mechanical hard drive for this type of use cases anymore. And state sync is mostly limited by disk IO and not bandwidth. So this is a very practical issue that probably 80% of the population trying to run a Geth node hits. They've been trying to fix some of that using new approaches to networking, such as snap networking, for example, to do better at reusing some of the components and reduce the size of the download. And I think they're doing a great job. It's very difficult because of the sheer size and the activity on the Ethereum blockchain. Another one that I really love is randomness starvation, which just hit me 2 weeks ago. Really interesting. I was running 2 Besu nodes on one machine, which is right here. And I started having all sorts of issues where it was taking up to 6 seconds to get a random number out of my /dev/random device. And to show you maybe in more detail, here is a JStack. If you're familiar with JStack, it allows you to take a view of all the activity in your JVM at a given instant. So you can see all the threads and where they are. What's really interesting about this particular JStack output is that it shows that everybody's waiting on a lock. What does that lock do? Well, it's the lock that allows you to generate a random object. You want to make sure there's only one random set of bytes being generated otherwise you may be reusing it across different cores, right? So the JVM is going to lock and make sure that you're not calling that twice. And because of that, you can see here in the catches here, right, that everybody's waiting on this particular thing. The problem is, of course, this randomness is used by everything in the Ethereum client, from generating blocks to even more nimble things like recovering a signature. Here in that particular case, it's sending a packet for discovery, to connecting and handshaking with other connections. And all those things start to compound each other to the point that your machine crawls to a halt eventually. So even if you think that you've got plenty of memory, you have the best I/O you can think of, there are still ways for you to get hampered by very interesting factors about your server. My particular server here is using entropy from keyboard, mouse, and network, right, to be able to generate random numbers. Well, I'm not typing anything. I'm not letting my toddler touch the keyboard these days anymore. And as a result, the entropy has been pretty poor. The fix, hopefully coming over USPS in a couple of weeks, crossing fingers, might be a USP-driven entropy creation little addition to my machine that allows me to plug it in and generate additional entropy. Okay, so we talked about all this, and I just want to also do a checkpoint. While we're having those very basic and critical issues about how we operate, the rest of the world out there is enjoying all sorts of very interesting capabilities and really getting really sophisticated about how they run software. And I think we should never lose sight of that, right? So if you look at any cloud-based software right now, they have high availability, which means that it's never down as much as possible. We use CDNs, use S3, use all sorts of technology to allow things to stay up and as much as possible static and close to the edge, right? So multi-region, if not multi-cloud, to make sure that there's no problems. There's a set of disaster recovery in place. They know exactly what to do. If you have any data centers that was to come down in AWS, you know exactly how to rebuild it the same way. Next door, there's not any loss of data. Everything is ready to go. We have edge computing now, where you're using all sorts of closer to the machine computing to make it even better and remove latency to go faster at serving customers. You're starting to see Lambda and serverless become normal. I think it's been normal for a while now, actually, where you have the ability to decompose everything you do into smaller services and therefore reduce a little bit the exposure of a bad piece of code so it doesn't take down the whole system. And dear of mine, this topic is all about observability. So full observability, I really see pioneers like Honeycomb, but also Splunk and others seeing push for a better way of doing distributed tracing. Honeycomb, for example, was saying we're going to have huge traces with the context of everything that's happening. We'll be able to centralize all this data together and make sense of it. And we're seeing metrics everywhere. Well, we're nowhere on this, right? We're nowhere in this level of maturity. We're still operating for a while, like it's going to run on your laptop, and it's been hampering a little bit how we think. So in this talk, we'll go a little deeper into some of those discussions, and we'll see what's coming as well. So operating a node, the best practices are still very much something I watch every so often, is this talk by Peter Zilagi, the Geth lead, and hopefully I didn't butcher his name too much. He, in this talk, talks about all the work that they had to do to operate Geth properly, how to make it really perform. What's really interesting about that talk is that he throws out the window all sorts of things about just looking at your software. No, he's actually looking at the whole machine, and he's actually dedicating the machine to run Geth, right? So he's going to look at memory use, going to look at I/O, going to look at swap, all the things that you would want to be able to completely understand the picture of how it performs. And you also have all the metrics exposed by Geth itself, right? So how many blocks are you able to receive, number of transactions per second you can generate, et cetera, et cetera. In this particular talk, he goes a little further. He explains also in terms of operations, how they go about organizing all the metrics into dashboards. This is something that we have written at Splunk. We have built an example set of dashboards for that as well. And he explains, and this is becoming more specific to his work, that they run experiments, right? And they change some of the factors of how eea-eth performs and test it using this approach. And they can actually see, for example, that some changes have beneficial aspects on some of the use. For example, they may reduce memory use, but they actually may hamper networking. So it's really interesting that they are trying to have a complete holistic view of everything happening with their node. We've been recommending that as well. And there's some good documentation on ethereum.org if you're interested to look into that. So the best practices, if you want to run a mainnet node today, it's a good start. It gets you somewhere in the sense that you may know at this point that you will need to have good IO. You will need to actually leave that node alone as much as possible. And we'll talk about how that becomes really hard in a second. So when you run a node, one of the things that people don't realize right away is that you're actually running 7 different network connections that do completely different things, that have different security profiles, that require different ways of thinking about them, that may need to have different types of security associated with them, right? So one of the problems you may have is, well, let's go into this. When you operate a node, you start with the most popular port, which would be RLPX, and RLPX stands for Transport over RLP. RLP stands for Recursive Length Prefix, which is just a fancy way of saying we're going to send all the bytes from all your blockchain over a secured connection. So that port, for example, 30303 is the default one that's been used for that. This is a TCP connection. It's persistent. And usually you would want to go to up to 25 peers, right? That's the default. You can actually increase that substantially if you want to get more out of it. One of the dependent of that port is to use discovery, and discovery has a completely different profile because now you're using UDP. So UDP packets have to be small. They're lossy by default. They can kind of spam around, make sure that you actually get discovered on the network. The idea for you is to participate freely in the network and not just have 2 or 3 connections. So you want to become a beacon of all those other nodes that you know about and share that knowledge with others. And the idea is that you create this way a mass of nodes that know each other enough that you cannot be kind of eclipsed away and manipulated. The other port that most people actually use day to day is JSON RPC, which is going to be open on 8545. Well, this is where your problems begin, right? Well, those ports, you want them to be open and free and clear to the public. This one, you definitely want to keep to yourself. There are a couple of reasons for that. We're going to go into this. The JSON RPC port itself is how you can send transactions, how you can see the data, how you can see what's going on with your node. You can ask questions about the state. You can, the if.syncing output in that bug earlier was from someone actually connecting using eea-eth attach to that JSON RPC port and asking questions. Kind of the same idea here. It's the exact same functionality with WebSockets. So you want to have a different port for that. And then we have things which are a bit more exotic. One is if you want to enable mining and folks to be able to connect to you to send solutions, right? And for you to send jobs to miners, you would want to open a Stratum port. That Stratum port is supported by Besu and it's not supported by eea-eth, if I remember correctly. If you want to participate in the network health and send statistics about how you're doing, you can connect to an ifstat server, which is going to be remote. This is a WebSocket connection as well. It's usually encrypted, but it's also, and this is important to understand, it's also going in 2 ways. You're sending data, but the server may also ask you information about how you're doing. It can ask for blogs, it can ask for your history, and there's some manipulation you can have there. Finally, you can expose all your metrics, Prometheus metrics in particular for eea-eth. For Besu, we also offer Prometheus metrics, but you can also use OpenTelemetry. So now you have all this exposure to the rest of the world. and you're going to have to manage all those different risk profiles and make sure you understand where you're going with this. And on top of this, in a private use case, all those use cases become even more poignant, right? So for example, RPX might make sense to be open to the world, but frankly, you'd like to keep it to yourself and like to keep it connected to just a set of nodes you would want to talk to, right? So how would you go about creating a sort of a dedicated connection for this? So a good idea also is to understand how your node, when it connects to the rest of the world, is going to behave. And the first thing you need to know is that when we start the first time, any nodes, will be eea-eth or Besu or frankly any Ethereum client, you're going to create a node identity, which is going to be your identity on a network. When you do a handshake, when you connect to others, the first thing you do is you send your identity. It's very useful for Chrome because for private enclaves, you actually use that identity to know who to talk to send private payloads so that you can actually find ways to identify private partners, right? So if you change that identity, there may be some side effects in Chrome where you might not be able to be reachable as much. And it's also interesting because there's a danger there right away where some folks could actually scrape your identity and start looking at you and see how are you doing, right? How long have you been online? What are you doing with all this data? Are you sending transactions, or are you just passively listening to the data that's happening on the network? This is on mainnet that might be lost in the flood of information and data. On private networks, it's a lot more fun to see exactly who's talking to who, right? So it's interesting to see if a particular node is just passive or it's sending a lot of transactions. What are those transactions? When are they logged? You can actually timestamp all of them. You can start doing all sorts of profiles and see who is sending when, what type of data. So a good fun example here is that this is an eeth2 developer saying for the Nimbus client, and especially for the eeth2 client there, they are going to change the ID at every startup. It's making life miserable for everybody else who is trying to refer to them as a static entity, meaning you won't be able to say, oh, I got this ID, this IP, because they change on restart. And that confuses crawlers, right? But at the same time, it allows you to be more private. So this is an interesting development where we have to do a trade-off between being easily reachable, or being harder to catch, right? So secret management, the next step is, and this is only, I think, in eea-eth, you have the ability to have accounts attached to your eea-eth nodes. And this is kind of a scenario you would want to walk away from as much as possible because, while it's very useful to have an account associated with your eea-eth node, now you're running your private key associated with software that is actually in touch with the rest of the network and could be hacked or could be manipulated or could be at the mercy of other operators, right? So if you have a disgruntled employee or someone that you give access to that node, they may be getting access to your account keys. And the best way, of course, to manage secrets is to just separate the concerns, remove all the keys from all your accounts keys from your node, and run a signer such as a consensus if signer, for example, which allows you to do all sorts of work with this. For Apache 20, which is an Apache project that I work with, we have built a very simple example of a wallet and faucet built on top. And the way we built it is that the faucet would start and generate a key pair for itself, encrypt it, keep it to itself, and only give us a public key. So when it starts, the faucet is always empty, and then we feed eeth to it so that it can start act as a faucet, right? And the good way to do that going forward would be to make sure that this private key is never retrievable from the outside. It cannot be manipulated. Okay, so security. Interesting. Ethereum security for data at rest is pretty much nil because we're using RocksDB for Besu, we're using RocksDB and other things like that for eea-eth. So if you don't encrypt your hard drive, you're pretty much asking, like, anybody can come in and can do a couple of things. One is they can take a copy of your public blockchain data. Like, big deal. It's probably not a big problem, but they can also manipulate and corrupt it. And it's really hard to do a transition or to go back to what it was before, right? So data redundancy, the way data redundancy is done by operators right now is that you run multiple nodes. That's the only way. if you want to make sure that you have a failover, you pretty much have to have double the hardware. In terms of security, a big hole that's been over and over, it's been talked about, it's good for me to, I think, mention it here, is that you have a JSON RPC REST interface, which allows you to interface with your clients, and you can do all sorts of things. One of the things you don't want to do, for example, is to expose too much of functionality. You can expose things like just getting data from the chain, sending transactions. We can expose things such as the admin capacity. The admin capacity gives you peer count, information about things, also allows you to remove blocks from your blockchain. So someone could actually come in and send a malicious command and say, remove and erase all data from this node, and the client would follow. So you definitely want to make sure that you get that right. The JSON RPC security settings itself are a kind of a maze. You need to make sure you understand all of them, because they have to do also with web. They have to do with how you're going to interface from the browser with your node. So you need to make sure you have cores in place, you have host allow list, so that you don't get yourself in trouble where someone could, sideswipe your host, get into it through a direct approach. And you can also use authentication. So on this one, basic auth is well known. It's been used quite a bit. We're seeing for some providers, such as I think Microsoft, we're looking into having OAuth authentication. My favorite approach, you don't expose JSON RPC to the outside world. It's too complicated, it's too messy, and also it doesn't scale well, because the same process and the same memory that is being used to do all the work around the blockchain, transitioning blocks, making sure you keep up to date with the chain, is probably not a good idea to share with people trying to DDoS your node, trying to understand, every half a second asking for the best block number, things like that. Instead, use a JSON RPC proxy. There's varnish, right? You can just simple varnish where anything coming through is going to be cached as much as possible. I'm also working on a JSON RPC proxy, and I'll put a reference at the end to that. You can take a look. Network security. Well, network security itself is a ton of fun because it keeps researchers happy and humming along. It's been years now. And the best bread and butter attack that we talk about a lot in those circles is eclipse attacks, right? So you come up on the network, you ask for a number of peers what their best block is, and you find yourself talking to people who are on a different fork, who are trying to manipulate you. What they do is that instead of giving you honest peers, they keep on giving you more peers that they control, right? And they even mirror, for example, so they don't have to run that many nodes. And as you connect to them, they start sending you data that they own, that they have decided to mine for themselves, right? Maybe using selfish mining. And before you know it, you're on a different track from everybody else, and you're being manipulated. So all your transactions go into a different approach, and they can use those transactions to do all sorts of market manipulation. That's a scary story. Hasn't happened too much, right? The reason for that is we have thousands of nodes. We have well-established set of boot nodes now, which are being managed by the Ethereum Foundation. Thank God for that. They're here. They give us, and they're already embedded into the software client by default. So when you connect over those, you connect the IP, it's direct, and it works pretty well. The next type of attack that's been used over the life of Ethereum has been DDoSing all sorts of nodes, right? So having all sorts of reputation for peers has been a way to go about this. For ETH2, it's even more poignant because so much more is happening around the network. You need to have fast propagation of votes at the stations to come to consensus. So how to do the best gossip and how to have a way to reward nodes that perform well. If you go into the DevP2P specification, you can see all sorts of use cases where they're trying to discard actively nodes that don't respond correctly or perform poorly. So it's really interesting to be able to get to the bottom of some of those reasons. A new way which has come to Besu as early as last month is to not only do RPX, which is encrypted, but to even have a TLS connection. So it's already encrypted by default. And then on top of that, you encrypt over RPX. The idea for this is to make it, I think, more in compliance with regulations. TLS is better because you can use FIPS 140 type encryption. It's also more an industry standard, so it's not going to raise as many eyebrows as some weird, encryption scheme that was just created for Ethereum. And finally, in terms of network security, so there have been some really interesting changes around that for mainnet, where initially you just had boot nodes and you were connecting to them, and then it would take a while to do discovery. Eventually, one of the engineers on the Geth team built a DNS-based security set of nodes you can connect to using a Merkle tree stored as text DNS entries on a Route 53 based host. So you can actually now connect to over 1,000 different nodes on startup using this approach. And it's called DNS discovery, supported by Geth, supported by Besu. So DNS is really useful in that case, really helps. However, now you're actually connecting to the DNS server and asking every so often, right, where is this going? And you need to make sure that your DNS is up to date and it's working correctly on your node. Discovery 5.1, that's the latest that's used by eeth2. Right now for eeth1, we use Discovery 4, which is pretty basic and it's not using any encryption whatsoever. In Discovery 5.1, I see a lot of interesting changes. I think we're coming also from the eeth2 implementation team, trying to make this a very foolproof type of discovery network. And that discovery network in between 5 and 5.1, what they did is they added more encryption, added an actual handshake over UDP, which is tough to do because of the asynchronous and lossy nature of those packets, and allows you now to have more anonymity in your UDP packets. So it would be harder for people to find out that you're running an Ethereum node on this network, which is what you would want ideally, is to make sure that you don't get detected by your provider and you don't get slashed or you don't get in trouble because someone's starting to shut down your network because they see you're running a bunch of Ethereum nodes. This is not just an Ethereum problem. Here's a fun one, right? This is taken from the Hyperledger Fabric discussion. Here's a poor man who's got Hyperledger Fabric instance, been running production for about a year. Then he's using certificates to identify and have authentication between all the peers and nodes. They run out. How do they go about changing that? How would they even get help about going about that in a proper way, right? And the feedback is, hey, why don't you just update core YAML and restart everything? This is really difficult when you have only one node out of 10 in that network. So account management, this is really interesting. You want to make sure, and this is used by scammers today, you want to make sure that you create as many accounts as possible to not get as much identified when you're doing private transactions, for example. You might want to be able to be a little more sneaky about how you connect and how you exchange private data, because your sender and your destination are actually still part of the payload. If you're familiar with BIP32, let me introduce it to you again. This is a way for you to derive from one private key a number of different public keys. So you can actually have all sorts of additional wallets, and for each of your transactions, you can have different different public keys. So you can actually make sure that your transactions are not traceable right away to you. And this becomes useful, for example, when you're mining, you might want to be able to separate all your mining between different public keys. There's only one problem, is that if you try to move all that money, then it may be fragmented across different accounts, right? So if you didn't really solve it because you now have 10, 12 accounts, and maybe you need to move that to different places. Okay, upgrade policies. This is a thing I do, I guess everybody does in this space now, so we just watch Twitter, Discord, GitHub, all the things we can think of. And it's really interesting to be able to even follow how those teams debug, how those teams work through all this type of issues. This is from one of the developers from eea-eth, Martin Swinde, and he was saying, oh, 2 weeks ago, they had a bug and a critical patch was issued for new release of eea-eth. How was it possible for them to, they made sure that all the miners were aware of the changes. All the miners had upgraded in time, and that saved them from having a very bad moment where someone would come in, introduce a bug into the chain, and then half the clients would go one way and half the clients would go another. Right? So the mining power and the hashing power is important and needs to be prioritized when you do an upgrade. Every hard fork, but also for critical fixes. Okay, so now we're getting into the stuff dear to me. I'm a big fan of telemetry. I work at Splunk. We want to get more data. And one thing that Splunk has done is sponsor the OpenTelemetry project. We started by looking at the kind of the default that's used by all the projects out there. It's been Prometheus. And now with OpenTelemetry, you can also ingest Prometheus metrics, or you can choose to have OpenTelemetry push all those metrics directly to an endpoint of your choice. The way they've built it is that the auto collector sits in the middle of this and allows you to collect metrics, traces, and logs using this collector and to correlate that to each other. So now your metrics can be correlated to your traces. Your logs have information about where the data was collected. So, your log line that just says error, this happened, you can say which pod it was in your Kubernetes environment or which machine is coming from. You can annotate yourself a lot of those labels, and you can also map that between traces and logs and metrics. So this metrics is related to that trace, for example. There's a big family of standard around this, and Jaeger and Zipkin, for example, for tracing were the first. Now OpenTelemetry is taking over, and it's making it possible to interoperate between those standards. One thing that's interesting for tracing, and we did that for Besu, is you can have a way to propagate a trace between different actors in a distributed fashion. So let's say you have a if signer, you're talking to Besu, you have Ethers.js and working from your web session, and your web session itself is inside a mobile app. Well, I can actually go as far as saying a trace will go from my mobile device to Ethers.js mapping the headers to the signer being able to do all sorts of work to map this trace, and even Besu registering the trace and adding additional information. We can then collect all this information and retrace it in a visual way, so you can see how much time is spent where. You can see the performance cost of this type of queries. You can identify issues, and you can even identify who's having issues, right? So is it a particular population? Is it a particular type of phone? What is going on? What type? When is that happening during the day, etc. And the logs are dear to me because they're the oldest piece of data that's been available forever. Right, this has been kind of the grandfather of every piece of telemetry out there, and they've really moved a lot around, those modern new ways of thinking, such as having loss severity being now standardized. You have the way to map and log with fields, so you can now not just put a message, but also have a structured message being put out, and all of that can be exported as JSON right away, which allows you to do very rich type of instrumentation and monitoring on it. So upcoming OpenTelemetry will support unstructured data, so we will be able to also export all sorts of interesting things from a client. It could be all your Stratum solutions. It could be anything about your blocks, your transactions, your trace from the EVM. All of these data, it's extremely useful, extremely rich, and would be available to people who operate the nodes to make more sense of what's going on. So what's coming? I see a few things coming, and these are my opinions. I'm pretty busy these days, so maybe I'm missing something, but you tell me. I see a lot more complexity coming to the mainnet. The Randomness exercise was a great way of looking at it from a very practical angle. So what they did is they have if1 clients now connecting to eeth2 clients over a JSON RPC endpoint, which means that the JSON RPC endpoint, which I just talked about earlier, this very critical piece of infrastructure, is this port that allows you to control everything about your node, is now also used as part of the consensus algorithm for eeth1 and eeth2. That is probably not the way it's going to end, of course, right? There's going to be a lot more richness to that part of collaboration and how to make it easier and faster and remove any latency between those two clients talking to each other. And that's going to be the merge, right? So it's the mainnet clients are going to become, at the same time, pretty hungry on I/O because they require disk. And they're going to become pretty hungry about networking because that's what eeth2 requires, right? We'll need to be able to collect the best of both. And one way to do that might be to separate even more the infrastructure and make sure that we have beacon chains which are more, adept at doing a better job at the execution. So, and we have beacon chains which are beacon chain nodes which are more adept at gathering attestations and creating consensus. And of course, we have cross-chain now, we have L2. There's a whole lot more complexity coming on that. It would be interesting, and the discussion I'm having with EEA, I would love to have a way for us to standardize on the new transaction type that would just store the hash root of L2 transaction, for example, or baseline, or anything around quorum and private data. So we would be able to have a bit of a standardization around that space. I want, and I would like to see more maturity from our solutions, especially right now that we're just running a bunch of redundant nodes all over the place, or we're being providers for the privilege of getting data. I'd love to see clustering, high availability take hold and become a standard norm for everything that's going on with Ethereum. And I want to be able to see backup, restore, and snapshots. So we're seeing some early move towards that. Thinking about Aragon, for example, where they were making snapshots available as BitTorrent. So very interesting and cool ideas. We'll see where that goes. And well, this is the year, so let's talk about enterprise for a second. I see more complexity coming from baseline protocol, which is really helpful to bring a lot of maturity and new actors into the space, and especially around mainnet. And I believe we're just barely getting started with consortiums. And by consortiums, I mean 10 companies trying to work with each other over a private network in the dark, trying to see how they can best work together. So to learn more, I made the few links available to you if you want. I'll put them in the chat if I get a chance by the end. I can talk to you a little bit about my MolokDAO proposal, which was approved end of July, which is all about creating a JSON RPC proxy that can be metered, throttled, has the ability to cache all sorts of responses for a bit of time, and is now part of the Apache 20 project, which is why I put the logo right here. Just off the press this morning, we had a new blog post on OpenTelemetry being the key to the future of software. And frankly, with a slant on, hey, you want to be in DevOps, this is a good way for you to really sharpen your resume. I also linked here what we at Splunk have been doing for blockchain, how we can help you, how you can do better with monitoring. And we have a complete view over your infrastructure using Splunk. We have here a blog post about Besu and how we made it possible to see traces and how we can actually understand the time it takes to sync a block using tracing inside Besu itself. And the last one, just happened to talk about that just before this webinar, was a document that I donated to the EEA about best practices to operate nodes, which goes into even more detail and is a lot more prescriptive about what we do here. And I believe it's worth maybe showing you just for a little bit. So this is a document that is currently sitting inside this GitHub repo. If you're interested, you can take a look. I would love to get feedback on that. It's got everything about development, testing, and blockchain operations, from all the things that I talked about today, such as encryption and rest, type of, the sizing of the machine, how you would set up your firewall, your Genesis block generation, how you go about that, and there's a maturity model about how you would operate this type of infrastructure, right? So you can actually check all the requirements and make sure that if you check them all, hopefully you're in good shape and you can operate safely. Okay, we talked a lot. This is my information. Do you have any question at this time? Okay, all right. Oh, you're using the chat. Okay, hello, hello. Awesome presentation, thank you. Well, you are welcome. Thanks, Ken. So, I'll take any questions you may have, anything you'd like to. What are the most common attack vectors you're seeing? The JSON RPC port is the most common attack vector, followed, so, you know, pretty much we have scrapers going around the internet looking for open ports for 8545. If you think that you can open port 8545 just because you're developing stuff and just having fun, please don't. This is not going to end well for you. What you would want to be able to do is to SSH into your instance and do a -L to pass your port 8545 to your local machine. That will allow you to use MetaMask with your remote connection. So you can actually connect to it, you can perform all sorts of transactions to your remote machine if you want to. What are the top 2 uses for the telemetry at this point? The top 2 uses would be, one is to just do performance monitoring. So make sure that you're able to perform on the network. You know, eea-eth, they have multiple very metrics that they care about. One is peer count. So am I losing all my peers? If you're losing all your peers, maybe because your node's in distress, is able to keep up with the rest of the network. Now you're timing out. Before you know it, peers are dropping you because you're not responding fast enough, right? Your handshaking is too slow. You're not able to encrypt your messages fast enough. Your CPU is in disarray. You're not able to work with the rest of the network. So peer count is a big one. The other one that you want to be able to see, are you up in sync? And this is a Besu metric, which is worth what you can hope, right? So Besu has a way to see all the peers it knows their best block, knows its best block. They do simple subtraction, best block that I see versus mine, and they see if you're less than 5 blocks away from the head, am I in sync or not? If you're in sync, then it's a good time to go and central actions, do all sorts of work, because you can actually be sure or somewhat assured, because you don't know the rest of the network, that your transaction is going to be exercised against the head and the latest of the network. And which one do you see becoming critical as crypto grows? I do see a whole lot of attack vectors around networking, and especially networking attacks that will be coming from the fact that we're trying to combine network-driven security of a stake, where right now we might be a bit more resilient or frankly wasteful with proof of work around those approaches. So I would keep an eye on, you know, gossiping, all the ways that need to be set up to gossip, making sure that you have enough in your group and that you're able to connect to others fast enough. Okay, so I have a question here in the Q&A. What is the best way of minimizing the costs for operating multiple full nodes, assuming they are run on cloud? It depends on the trade-offs you want to make. So you could definitely use a cloud service to do the work. So for example, if you go to Amazon AMB, you can run eea-eth on mainnet right now. You can, you know, just use that service to get by. What they would charge you is about $300 a month. This is from their pricing page. So that would give you kind of a good baseline of what you can hope from the best providers, right, who are already seeing the latest and greatest. But at the end of the day, what they do for you is they spin out these instances on your accounts, they run it on your behalf, they will take care of upgrading the nodes and things like that. So that's currently in preview. You can probably also use things like AnyNode, which have been around for some time. But again, you're giving away some of your operations capabilities to work with others. Then it depends. If you're on cloud, then you need to start playing dirty, right? So there are a couple of things you can do. One is, if you can, and if you have the appetite, I'd recommend to have you look into ARM, because the EC2 ARM instances are much cheaper, right? But that will require you to actually go through the steps of making sure GEF or whatever software you want to run is going to work well on ARM. You want to use all the cloud tricks, such as using reserved instances, using spot instances for syncing. So you would start, when you sync your instance at first, you go for a big instance, lots of memory, plenty of storage. You go really, you burn a bunch of dollars. Once it's synced, your requirements change drastically because you're no longer trying to get as much data crammed into a disk. You can slow down, you can go slower, you can reduce the size of your instance. But all those things is you're chipping at the margins of your cost. The biggest cost to operate a node is how much time you're going to spend operating a node. That's really difficult right now to automate away. What are your thoughts on using JWT for security? Well, we talked about that a little bit with our using OAuth, right? So I think this is fine, as long as you know what you're getting yourself into. So I also think, and I'm going to repeat that again, this is, I do not think that blockchain clients should do everything. There should be layers of protections before you get to them. So if you want to use something like Nginx, for example, to kind of, filter the flow of requests coming to hit your node, that'd be a good idea. If you want to use something that's a little more beefy, like this JSON RPC proxy I keep harping about, that would be a good way for you to also get by. Any other questions? I'm going to copy here, put it in the chat. So you can reach me at Antoine@io. There's my website. And you're welcome to look at my GitHub, connect to me over Discord or whatever you want.
All right. Thanks, Antoine, for joining us today. That was a great presentation. So you've already put your social media handles in the chat. So all attendees, feel free to follow Antoine's work. For more additional information about joining the EEA, please reach out to membership at eea-eth.org, or you can visit our website. You can also follow the EEA on Facebook, Twitter, and LinkedIn, and that's been put in the chat for you. So thank you again, and this concludes today's EEA Education Series webinar.
Thanks, everyone.